Our lesson for today will be looking at chemistry 1502. The topic for today is isomers. We'll be looking at stereoisomers. We'll be focusing on optical isomers. Lesson 103, let us start. Like I said, a tree of isomers is very big. Under optical isomers, just know that we have enantiomers, and diisomers. Then in this lesson we'll be focusing on enantiomers. Before we look at enantiomers, we have to understand the optical isomers. You should know that optical isomerism is one form of stereoisomerism. In optical isomerism, the isomerism present at a tetrahedral center. When we talk about a tetrahedral center, we're talking about a carbon having 4 different groups, also known as a carbon that has a chiral center, or we can also say a carbon that has an sp3 hybridization. Suppose we have this structure. Let us put chlorine here, let us put OH here, then we can put another hydroxy group here. And looking at this, we can see that this carbon here, it is a tetrahedral center, and also this carbon, because if you can check it as 1, 2, 3, we consider this as a group, and then we have hydrogen here as group number 4. So we have 4 different groups. Also this one will have 1 as the methyl as part of the group, 2, and then the hydroxy group will also be considered as a different group, and then we have hydrogen here, which is the last group. So these carbons here, we say this is the tetrahedral center. With the lesson that we've already went through about the chirality of carbon, we know that carbon having 4 different groups, it is chiral. So just a quick review. Let's say we have this carbon. We have X, Y, Z, and then we have hydrogen here. As long as it has 4 different groups with hydrogen at the back, we know that the dotted lines, they simply mean away from the page or away from you, and then this is towards you, and then these 2 are on the plane. So normally you will see a star on the tetrahedral center. Another way to represent a chiral carbon can be like this: CH2CH3, and then we have a methyl here, and then we can have chlorine towards, and then hydrogen away. Normally hydrogen should be away, especially when we have to name according to R and S. Or another one, we can simply draw something like this. We have chlorine, we have bromine, then we have fluorine, then we have our hydrogen here, and then our tetrahedral center will be here. So this is just a quick review of a chiral carbon, and all of them are sp3 hybridized. So if you have a carbon which does not have 4 different groups. Let's say there's 2 different groups, 1 different group, 3 different groups. You should know that those ones are actually a chiral, which is the opposite of chiral. We've already covered this, and the example would be, let's say we have this particular compound, or we can have let's say we have methyl here, or we can have carbon with a methyl here, and let's say we have hydroxy group and we have hydrogen towards and hydrogen away. So you can see that this, it has all 4 groups which are the same. This, it has 2 different groups. Actually, let me say 1 group which is different from the rest. And then this one, it has 2 different groups and the rest are the same. As long as you have identical groups, just know that you're talking about a chiral. Now, before we can get to enantiomers, let us look at the tips or guidance on how to draw the chiral molecules. Let's say we want to draw 3-methyl hexane. It has to be here. We want to draw 3-methyl hexane. Let me just quickly draw the condensed formula of this. So we have CH3, CH2, CH, CH2, CH2, CH3. Hexane, we have to have 6, 1, 2, 3, 4, 5, 6. And then our methyl group will be here, CH3. So the guidance on how to draw a chiral molecule. So the first thing, we have to identify the tetrahedral center. Well, the first step is to draw the IUPAC name of, actually the structure of this IUPAC name, and then we have to identify the tetrahedral center. We can see that this will definitely be our tetrahedral center. It has 4 different groups, which is, this group is not the same as this, so it's 1, 2, and then 3 with this hydrogen, and then 4 with this methyl. Once you're done identifying the tetrahedral, what you have to do, you just have to draw something like this, which represents the 4 different groups. And then this carbon will be our tetrahedral center, which is this one. Then just make sure our hydrogen, this hydrogen, is at the back, and then we can put the methyl here, and then we can put the ethyl, this part, it's this one, this part we can put it here, CH3, CH2. Actually it was supposed to be the other way around. It's CH2, CH3, and then this part we can put it towards CH2, CH2, CH3. It is easy. Now let's say we want to draw a mirror image of this particular structure. It is very important for you to know how to draw the mirror image, or to identify. Let us say we put a mirror here. If we put a mirror here, we are going to have something like this. The moment you can be able to draw this, just know that it will be very simple for you to be able to tell or to be able to identify the geometrical isomer CH3 here. Then here we have CH3. Before we get to today's topic, try to draw a chiral molecule of this, and also draw a mirror image, just to check whether you do understand. So you can pause the video, draw the three-dimensional structure of this particular molecule, and also draw the image of this molecule. So we start by drawing the structure, which is Cl. We can see that the tetrahedral center is here. Then we can start by doing this. Then we can put our hydrogen here, which is the hydrogen here, and then we can put our methyl here. We can put our ethyl, and then we put our chlorine here. If you put an image, we are going to have something like this. With methyl here, our ethyl here, and our chlorine here. I hope you got this one correct. Now, with this information that we have, let us integrate it with today's topic, which is enantiomers. You should know that if a compound is chiral, it can exist as an enantiomer. And if it is achiral, it cannot exist as enantiomers. So when you talk about enantiomers, we have to talk about those molecules which they have a tetrahedral center. Now this is today's lesson. Enantiomers are stereoisomers that are mirror image of each other, and they are non-superimposable on their mirror images. In other words, what we're trying to say is that if one isomer looked in a mirror, what it would see is the other one. The two isomers, the original isomer and its mirror image, have a different spatial arrangement, and so can be superimposed on each other. All enantiomers are chiral. Let us quickly look at this, just to explain this quickly. We know that you might have seen the definitions of chiral and achiral, enantiomer. Let's say we put a mirror image here. We know that what we'll see, we are going to have a methyl here, C3H, and then we are going to have hydrogen here. We have CH3, and we have chlorine here. This is the mirror image. Now we can take this as A, this as B. If I take A and I put it on top of B, do you agree that, let's say the blue one represents B, I mean A, we are going to have a structure like this. So in other words, it can actually fit exactly on top of structure B. The moment the mirror image can fit on top of another one, we say this is superimposable. You should know that this cannot exist as enantiomers. Or we can say these are not enantiomers. That is the easiest way to identify enantiomers. Let us quickly look at another one. Suppose we have the structure hydrogen. Let us put OH, and then let us put chlorine. We can put bromine here. Then let us put an image. Putting an image, we can see that we are going to have a structure like this. We have hydrogen, we have OH here, and then we are going to have Br this side. Remember, it is very important for you to know how to draw a mirror image. So in this case, let us say this is A, this is B. We take A, we put it on top of B. Let's say this C, the pink C represents the structure A. And then we are going to have hydrogen here. We are going to have chlorine here. We are going to have a bromine here. And then we are going to have OH here. Now you can see that it doesn't fit. It is not superimposable. Therefore, we can say these ones are enantiomers. And if you can check, we said all enantiomers are chiral. In this case, you can see that we do have a tetrahedral center because of these four different groups. Looking at the previous example, we can see since we have identical groups, it is going to be superimposable. Therefore, it is not an enantiomer. Now, before we close this lesson, let us look at another example. If we take this 2-chloroputane, which is one of the examples we've used, CH3, and then we have hydrogen here, we have chlorine here, and then we have CH, C2H, CH3. We put a mirror here. And then we can see that the drawing will be like this. And then we are going to have this, which is CH3, and then we have hydrogen. We have our ethyl here, and then our chlorine here. If we take, it's A, B, if we put it on top of, if we take A, we put it on top of B, you can see that it is not going to be superimposable, because we are going to have something like this. Our hydrogen will go this direction, and then our methyl will go this direction, and then we are going to have our ethyl here, and then we are going to have our chlorine here. Therefore, the two, they are enantiomers. And then with that being said, you should know that since we said it is 2-chlorobutane, this will be S2-chlorobutane. There is a lesson video whereby we look at RNS nomenclature, and then this will be R2-chlorobutane. So I hope in this lesson you do know how to identify enantiomers with an ease, and also you know what is chirality and chiral. That's it for this lesson video. This is Rahula HJ. Thank you very much.